Good afternoon, ladies and gentlemen. Here is a scientific article is presented on the topic Methods of improving power indices of electric drive active rectifiers for mine hoists. The research deals with analyzing peculiarities of using active rectifiers in frequency-controlled electric drives of underground mine hoists. There are developed MATLAB models aimed at comparing two types of control systems: hysteresis-based and the one with pulse width modulation. The research aims to analyze power modes and parameters of active rectifiers, quality of voltage, control, current and power of active rectifiers, and to determine ways of improving power indices of electric equipment of hoists, as well as provide power compatibility of electric equipment and underground mines grids. AC electric drives with FCSM frequency converter synchronous motor and FCAM frequency converter asynchronous motor systems came into use worldwide in the 2000s. In 2011, the skip hoist drive at Chernivtska underground mine was modernized in order to increase its hoist capacity from 25 to 35 and mining depths up 1,800 meters. That included replacement of the TDM system by the FCSM, one with the frequency converter produced by ABB. Greater driving power deteriorated quality of electric power in grids. At the 6 kV section of 150 6 kV Oktябrska substation, there are much more significant deviations of voltage than those at Leninska substation with the FCSM of the skip hoist. Truths, in our opinion. While designing technical tasks to upgrade the drives, one should analyze their possible influence on the mains and quality of power. This analysis should consider technical potentials of active rectifiers or frequency converters. To do this, the research simulates electromagnetic processes and analyzes power quality control indices in the grid. Parameters of the power converter transformer and the synchronous motor are in Table 2. This converter type is similar to the self-commutated voltage inverter, with the only exception that the diagram works in the rectifier mode and ensures the power factor close to 1. The key switches of the active rectifier can be controlled by the pulse width modulation system or the hysteresis control system. Figure 2 presents the diagram of the rectifier model with the pulse width control system. In simulating, dynamics of electric parameters of the active rectifier is under study. Figure 3 shows an oscillogram of the output current and voltage of the active rectifier. As is seen in the given diagrams, the control system enhances high-speed performance of voltage control. Figure 4 contains diagrams of the input current and voltage of the active rectifier. As is seen, the current curve coincides in phase with that of voltage, thus providing the power factor of 1.0. The form of the current curve is determined by the two-level active rectifier and ratio of active and inductive resistance of the power transformer of the mine substation. The time of that put voltage increase to reach the set value makes 0.02 sec. The pulse number is m equal to 6. Figure 5 shows the diagram of the active rectifier model with the hysteresis control system. Figure 6 contains the oscillogram of the output current and voltage of the active rectifier, while figure 7 presents oscillograms of the input current and voltage. As is seen, the diagrams of the output voltage and current of the active rectifier with the same parameters of the model elements indicate overall control of these parameters, as absence of pulse width modulation reduces speed performance of control over output voltage of the self-commutated rectifier. To reduce voltage over control, the control system and the output voltage controller are to be readjusted. The time of the output voltage increase to reach the set value makes 0.02 sec. The pulse number of the rectifier scheme is m equal to 6. The curves of input currents of the active rectifier with the hysteresis control system have significant deviations are compared with the active rectifier with the pulse width modulation control system. The form of the parameters can be improved by changing parameters of the input filter of the active rectifier. There are MATLAB researches into the drive model of FCSM system with the active rectifier. Figure 8 presents a drive model with the active rectifier. This model has units of the three-phase voltage source, the three-phase voltage and current meter, the self-commutated synchronous motor with subsystems of the synchronous motor, the rectifier, the DC chain, the inverter, the speed controller, the rectifier controller and the vector controller, the demultiplexer of motor parameters, and the calculator of active and reactive power from the grid. Figure 9 contains diagrams of the rotor speed of the synchronous motor, electromagnetic torque, active and reactive power. As is seen from the speed diagram, the static control system after the load surge reacts to dynamic speed slumps and monitors the signal by the speed. The diagram of consumed active power is determined by the motor speed and torque. Reactive power is minimal and provides the power factor too close to 1. The system is also able to generate reactive power. The system has four control channels: by the input reactive current of the active inverter, by the set output voltage of the active rectifier, by frequency and the pulse ratio of the inverter voltage. Conclusions. Analysis of the active rectifier mode enables determining advantages and disadvantages of these control systems and formulating requirements to improving parameters of the active rectifier. The structure of the control system of the frequency converter is also analyzed, this indicating a potential control over torque controllers, the motor flux, the level of consumed reactive power, and the power factor value. Application of the research results will allow determining structures and methods of adjustment of control systems of the active rectifier in the frequency control drive of underground mine hoists. The scope of further research will involve improvement of energy efficiency of active rectifiers and a reduction of their impact on the grid. This is the end of presentation. Thanks for your attention. I'm ready to answer your questions.